Welcome back to ACER Explained, and today I'm going through Section 3 of the ACER Practice Question booklet. In this video, I'm going through the final unit. Yay, we made it. Unit 17. So Unit 17 covers questions 48 to 50. As per usual, I'll identify the prerequisite knowledge and the reasoning skills that are needed, as well as some of the bootcamp resources that you can use for this as well. Question 48 is asking us that basically, since hydrochloric acid is fully ionized, what does that say? Okay, so it's given four options. The fact that hydrochloric acid fully ionizes, does it mean that its pKa value must be very negative? Does it mean that the total amount formed must be very low? Does it mean that the pool water must have been basic initially, or does it mean that it must be a weaker acid than hypochlorous acid? Well, first of all, we have to figure out what does it even mean for hydrochloric acid to be completely ionized. That basically means that it fully dissociates from HCl to its H plus ions and Cl ions, okay? And the compounds that do this are very strong acids, okay? So the stronger the acid is, the more this direction will be favored, and so the more hydrogen ions you'll have. So the Ka value is representative of how well an acid dissociates. It's the dissociation constant. And the pKa value is just an easier way to write this. It's the negative log of the Ka value. So the bigger the Ka, the more negative the pKa is going to be. And so if HCl is fully dissociating or nearly fully dissociating into its ions, then that's true. The pKa value must be quite negative because that means that it must have a high Ka value. Okay, so looking at the other options, we have the total amount formed must be very low. Well, that's not true because if it's ionized, then the total amount of ions formed must be very high. So this is wrong. The pool water must have been basic initially. Well, that's not necessarily true. Even if like a strong acid can dissociate, a strong acid can dissociate in basic or neutral conditions as well. So this is not necessarily true. And then the last option is that it must be a weaker acid than hypochlorous acid. Well, the fact that it's almost completely ionized tells us that it's quite a strong acid, and so it's likely, even if you don't know what the constant for hypochlorous acid is, it's probably not weaker, it's probably quite strong, so we can eliminate this. Either way, out of the four options, A is the most true option, so we can circle that one and move on. For this question, you do need to know a little bit about your acid-base chemistry, especially what a Ka value means and what it means for an acid to be completely ionized as well. So other than that, the reasoning that you use is the process of elimination, as well as just realizing that you don't need all of that information that's given to you. It looks like quite a lot, but you don't really need it for this question. And the bootcamp resources to help with this include the reasoning skills course, as well as the bridging courses on equilibrium principles and acid-base chemistry. Question 49 is giving us a series of dilutions and basically asking us, all right, so what's going to happen if you put 0.5 moles of calcium hypochlorite? So I'll put the formula there so that it's up there. So we have CaOCl, and this is given to us, in 10 liters of water. And then after you have this 10 liters of water solution, you add this to 20,000 liters of water. Okay, so let's start off by figuring out the concentration of hypochlorite ions in this initial little bit here, because that's what it's asking. It's asking about the concentration of hypochlorite ions. So when it dissociates, it's going to become Ca plus 2OCl. So you have 0.5 moles here is going to create 1 mole of hypochlorite ions. So the concentration here is 1 in 10 liters, so 1 mole in 10 liters. And so that's going to be 0.1 moles per liter. Okay, because you're in 10 liters, if you have 1 mole, then if you divide that by 10, you divide the 1 by 10 as well. So you get this here. Okay, so this is your first concentration. We're going to call that C1 because we're going to use the formula C1V1 is equal to C2V2. Okay, so C1 is 0.1, V1 is 10 liters, is equal to C2, which we don't know yet. That's what we're looking for. We're looking for the concentration, multiplied by V2, which is 20010, because you're adding the 10 liters to this. Okay, so you just add that 10 at the bottom. So you have 1 equals 2, C2 times 20010. Then I'm going to divide both sides by this number, 10, and that's my C2. So now how do I figure out which one of these is the correct option? So what I would do is I would separate this out. So first of all, I'm seeing 5 or 2.5, all right? And I'm seeing here that I have 1 over 2, which is 0.5, right? So I can kind of separate this out into 2 fractions. I can say half times 1 over 100. And I'm not going to include this 1 here actually because I realized looking at my answer options, it's not going into that much detail anyways. So I can just kind of glaze over that. All right. So I have 10,000. So when you turn these into decimals, you have 0.5 times 10 to the power of negative 1, 2, 3, 4. Okay, then when you have, when you pull this decimal over, so let's say 5, you have to decrease this decimal by 1, 10 to the power of negative 5, okay, because that means, you know, it's evened out. And so our answer here is B, 5 times 10 to the power of negative 5. This question required the prerequisite knowledge of that formula C1V1 is equal to C2V2. And the reasoning skills used here are just basically calculations, and you can find information about this on our bootcamp on the bridging course, moles and calculations. And then we also have an acceleration class on calculations and formulae to get that speed up as well. This last question is another calculations question as well. It's basically saying that which one of the following answer options, when the reaction goes to completion, is going to create the greatest amount of hypochlorite ions per kilogram. Okay, so that's very important because we're looking at moles and then we're also looking at per kilogram, which is going to be different because each of these have different molecular masses. Okay, so let's start off with NaOCl. So we have OCl, and that's going to just create, that's going to be a 1-to-1 ratio of OCl. So then now we just have to figure out what's the number of moles in 1 kilogram, which is 1,000 grams of NaOCl. And so we're given the molecular masses. So we have 23 for sodium, and we're given 16 for oxygen, and we're given 35.5 for chlorine. So adding these up, we have N is equal to, I'm going to do plus 16, so that's 9, and then 3, so we have 39, and then 39 plus 35, I'm just going to say that's 40 plus 35 is about 75 there, okay? So we have, and then we have the 1,000 grams over there. So we have N is equal to 1,000 grams over 75. And that's the same number of OCl. So I'm just going to say for option A is this. Then let's move on to option B. Option B is going to produce 2 OCl, hypochlorite ions. And now we have to figure out the molecular, the number of moles that are going to be produced. So with this one, we're going to have N is equal to 1,000 grams over, we have calcium, which is given to us as 40, around 40, plus 2 of our OCLs. So let's just figure out what OCL is together. So we have 16 plus 35, because we're going to be using this number again and again. So this is going to give us 51. Okay, so this is OCL. Okay, and then here we have 2 of them. So that's going to be 102. Okay, so here, this is the number of moles of calcium hypochlorite, but the number of hypochlorite ions produced per mole of calcium hypochlorite is going to be times 2, right? Because if I write out the equation, to ensure that it's balanced, we need to have 2 OCLs, right? So we have to basically just double this. So I'm just going to times that by 2, and so I'm going to say that the OCL number of moles is 2,000 over, I'm going to do 142. Okay, then we have C. We have our nitrogen, Cl3, and then say this reacts with water. Either way, because we have this 3 here, it's going to lead to 3 OCl. And so doing the same thing that we did earlier, 1,000, so 1 kilogram over, we have nitrogen is 14 plus 3 times 35. So I'm going to say 3 times 35 is about 105. So let's do 105 approximately. So, and there's going to be 3, so I'm going to times this by 3. So the OCl here is going to be 3,000 over 100 and around 20. All right, so actually, yeah, 120, around 120. Don't need to be too precise here. And then finally, we have the last equation here, and this one's a bit trickier. So we have Cl2 and O. And then again, we're just going to assume what this is going to look like. So we're going to assume that this is going to look like OCl plus Cl. Okay, so here, same thing, N is equal to 1,000 over, we have 51, which is our OCl, plus another 35. So we have 86, all right, over 86. All right, so now we have to figure out which one of these is the biggest answer option. Okay, so here the denominator is bigger, so this is going to be smaller than option A. Option A is going to be bigger, so I'm going to eliminate this. Then I'm going to divide this, or I'm going to multiply this by 2, so we get 2,000 over 150. Okay, and here the denominator is smaller, so that means, and this denominator is bigger, which means that this is the bigger option. And then what I'll do, the last thing I'll do is I will divide I'll divide this by 2, so that'll be 1,000 over about 71, and then divide this by 3, so that's 1,000 over 40. And here we can see that the denominator here is bigger, which means that this is going to be the smaller number. This denominator is smaller, so this is going to be the biggest number. So the answer is C. And that's kind of how I would go about it without trying to do the decimal values for each and every single one of the answer options. Again, for this one, it would help to have the basic chemistry knowledge about how kind of those equations work, and also how moles work. You need to know the mole and molar mass formula, because that is extremely high yield and important. That's your basic chemistry knowledge. The reasoning skills are just calculations. And in order to kind of brush up on your basics, we have the bridging course on moles and calculations there as well. So that brings us to the end of Unit 17, which is the end of the practice booklet. So well done if you're following along the whole way. I hope this was helpful for you as well. And like, share, and subscribe. And please give us feedback for us to improve and for some more GAMSAT help as well. So we have our Instagram at ThankFlipGAMSAT, as well as our podcast, ThankFlipGAMSAT, Nurses Doing GAMSAT, if you want to hear more from us. But yeah, stay tuned. There'll be lots of other ACER papers that we'll be covering in the future as well.